this is going to be a follow-up to the problem that I posted, just so that you can see the solution and how I worked through it. Alright, so obviously I moved the figure over. It doesn't look exactly the same as you have it on your sheet, but nonetheless it's the same. So part A on figure 1, say it's to pass the beam as it emerges through the prism. So here's our beam, right? And as the beam enters, it's just going to continue straight forward along this dotted line, right? Because it's coming in perpendicular. And then, right, we got to figure out which way it's going. You have to draw in your normal perpendicular. All right, and if this is on this side, this guy is going to bend down like this. Alright, so this angle then, right here, this blue guy, I'll do a little blue box. This is our theta 2. Alright, that's the refracted angle. And then this guy in here is our theta 1. So, A, done. Check mark. Alright, determine the angle with respect to the horizontal of the beam as it emerges from the prism. So what we want to find is, why don't we use yellow. We want to know this angle right here. And we're just going to call that angle alpha. So there's a couple things we need to figure out. So first, you can see that alpha is some part of theta. All right, so theta 2 is clearly alpha plus, okay, this little bit right here, which we'll call beta. Okay, you can use whatever variables you want, but that's what we're going to use. Now we need to figure out what some of these angles are. Right? And now here's the nice thing. We know what theta 1 is. Okay, or rather we can figure out what theta 1 is, because if this guy up here is 37, this is a right angle. That means this angle right here is 53 degrees. All right, they tell us that up here. Now, the normal in this surface of the glass is a 90-degree angle, which means that theta 1 is just equal to 90 degrees minus the 53 degrees. And so theta 1 is 37 degrees. And if you look alternate, I believe it's alternate interior angles, theta 1 equals beta. Okay, so beta is also 37 degrees. So now we can go ahead and figure out what theta 2 is. That's our refracted angle, right? So we can use the, we'll just label it right here. I'm doing part B, n1 sine theta 1 equals n2 sine theta 2. Alright, n1 is of the glass, so 1.5 sine theta 1, which we said was 37 degrees, equals n2, which is now in the air, so it's just 1 sine theta 2. Alright, theta 2 then, when you go to substitute this in, comes out to 65 degrees. Now, again, we don't want theta 2. We want the angle of deviation, right, which is that alpha. So alpha is going to be theta 2 minus beta. Okay. Which is just going to be 65 degrees minus, right, beta we said was 37 degrees. And so alpha is going to be just 28 degrees. Alright, and that's it for part B. Now part C, the prism is replaced by a new prism with the same shape, uh, the same position, the beam experiences total internal reflection, right? So that's where it goes in and it comes, instead of coming out, it reflects down, right? So we can demonstrate that. We can erase some of this extraneous stuff. Okay, we'll leave the normal. So if it comes in at theta 1, now it's going to be in, this is different now. If it comes in at theta 1, it's going to go out at theta 1, right? Total internal reflection, TIL. And we want to know what is the minimum possible index of refraction. Or in this case, yeah, just what is the n value. So we still start with n1, okay, sine theta 1 equals n2 sine theta 2, right? But when we're looking at total internal reflection, this outgoing angle, okay, going to be equal to 90. And that's such that sine theta is just going to equal to 1. All right, and instead of calling this theta 1, we call it the critical angle. Okay, it's the angle that's, once you hit that, it's the minimum angle such that it's no longer going to refract. And so essentially, right, we have n1, so we're in the glass. That's what we're looking for. Sine the critical angle, okay, which in this case, we actually know the critical angle. Right, the critical angle has to be 37, because that is what our theta 1 is. We can't change that. That's what it's coming towards that edge at. Equals n2, which is our outside. So just 1, and sine of 90, which is 1. So in this case, right, n1 is basically equal to 1 over sine of 37 degrees. And so that should work out that n1 is just going to be equal to 1.67. Right? Just to reiterate, n1 is inside the glass in this case, because that's where we're starting, and n2 is out in the real world, or out in the air. Okay, that's just what we called it. And so that is done. Check mark for that. So what we can do is now we can move on to the next part. All right, so now we have the new prism, okay, having that same value for n, so 1.67, or whatever you solved for, right, because it will carry through. And now we're in a liquid. And so we want to sketch the beam as it passes. So it's pretty similar to before. I'll use that light blue again. It's going to come in, it's going to hit this, and it's going to refract out. But this time, I mean, that's a little exaggerated. We'll draw that a little bit better. Okay, it's going to go a little bit less, right? Because now the n value out here is higher than before. Okay, before it was 1, now it's 1.33. It's not going to bend as much, right? When these two n values match, the 1.67, the 1.33, as they get closer together, you're going to reduce the amount of bend. All right, so we got to do what we did before. We got to draw in our normal. All right, and this time, that's it. We sketched it. That's what they're looking for, is the fact that it's closer. Now we want to determine the angle. Again, this guy over here. All right, we want to determine that alpha. All right, and it's going to wind up being just like before. n1 sine theta 1 equals n2 sine theta 2. In this case, n1 is in the glass, or in the material, and 2 is outside, so 1.67 sine 37 degrees, right? The path hasn't changed, this angle hasn't changed. What has changed is this, the alpha, the outgoing angle. And 2 in this case is 1.33 sine of theta 2. All right, and so theta 2, if you go ahead and solve this, theta 2 is going to work out to be, I believe it is 49 degrees. But again, that's not what they want. They want alpha. And just like before, alpha is theta 2 minus beta. And beta is still 37 degrees, right? Beta is just the opposite. If this is our theta 1, that's our beta. They are the same. And so theta, or alpha rather, is going to be 49 degrees minus the 37 degrees. And so alpha works out to be 12 degrees. All right, so hopefully this clarifies, put ourselves to check, clarifies some of the points that you might have gotten stuck on, or some of the stuff that you might have been confused about. All right, until next time.